Hello everybody, this is me Khalid Miraj Malik over again here with a new video today. In the previous video we have discussed open circuit impedance parameters regarding two-port networks. So taking the parameters forward, so we shall be studying ABCD parameters, short circuit impedance, short circuit admittance parameters, etc. today. So starting off with it. Today we study, the topic is short circuit admittance short circuit admittance parameters. Okay, what is admittance? Admittance is the reciprocal of our impedance. Admittance is written as y equal to 1 by z, where z is impedance. We have already discussed it in the previous video. Z equal to under root of resistance square plus XL minus XC, which is the aggregate reactance square. Resistance square plus under root of resistance square plus reactance square. So what y will be? Y will be y equal to under root of 1 upon under root of z, 1 upon z. So it will constitute, what is the reciprocal of resistance? The reciprocal of resistance is conductance G square plus, what is the reciprocal of reactance? The reciprocal of reactance is susceptance B square. So what is y, or what is admittance in the nutshell? It is the reciprocal of our impedance, or the property of an electrical circuit by virtue of which it allows a current freely to move in it. Okay, this was the basic definition of what is an admittance. So starting off with it, short circuit admittance parameters. This is our topic today. We shall not make the diagram for two-port network over again. We shall directly write the equation for it in the matrix form. It is written like I1, I2 is equal to, admittance is y, it will be y11, y12, y21, y22 with voltages of the input side and output side of the two-port network. You can see from the previous video we have made the diagram over there, V1, V2. So the equations in expanded form will be I1 is equal to y11 V1 plus y12 V2. This is the first equation, and the second equation will be from this side, I2 is equal to y21 V1 plus y22 V2. Equation number second. Okay. So finding all those four admittance parameters, in order to find y11, we would have to take V2 equal to 0 such that this expression becomes 0 and only this expression is left over there, and y11 will be I1 upon V1. So if V2 equals to 0, this implies y11 is equal to I1 upon V1. If V2 equal to 0, the voltage on the output side equals to 0. What does that mean? That means short circuited. What does this mean? This means, you can write, that is short circuit output side. Output side. Output side is short circuited. That is why we write admittance parameters as short circuit admittance parameters, because with all those four parameters there will come short circuit. In the previous ones there was open circuit with all the four. Okay. y11 equal to I1 upon V1. Moreover, if we see if we take V1 equal to 0, this expression will be 0, and ultimately if V1 equals to 0, then y12 will equal to I1 upon V2. Okay, so in this one you can see from this one, this is completely dependent from its numerator and denominator upon the input side. But in this one, y12, you will see the numerator is from input side and the denominator is from the output side. Okay. So, coming to the second equation, if this v2 equals to 0, then this second expression will become 0, and ultimately y21 will be equal to I2 upon v1. If v2 equals to 0, this implies y21 will be equal to I2 upon v1. Okay. And if here again voltage equals to 0 means short circuited, which one? The output side is short circuited. Here v1 equal to 0, input side is short circuited because the voltage is equal to 0. And if v1 equals to 0, if v1 equals to 0, this implies y21 will be equals to I2 upon v1, which will be a transfer admittance, because it has one parameter from the numerator from the output side and denominator from the input side. Okay. So all the four have been found, this one, this one, this one, and this one. A main thing to be noted here is that in the previous video we have discussed that the impedance parameters, those are always in series with some voltage source, but in admittance parameters the admittances will be in parallel with the current sources. Okay, so we make a diagram for the diagrammatic representation for this. Let it be, sorry, let it be like this. One dash and 2 dash. This one is end 1. The current I1 will flow from here. So what is y11? It is I1 upon V1. V upon I is, what is V upon I? That is impedance Z. Then I upon V is the reciprocal of that, and that becomes the admittance. Okay. So we have to write here we have I1, and the second thing is that voltage V1 is also here. The current I1 is also here, voltage V1 is also here. So there is no need to write anything with y11. Okay, we will write it will come in parallel as we have already discussed. Because the voltage V1 will be across this y11. And y12, if we have to write y12, it has current I1, that is here, but voltage V2, which is not here, which is on the other side, that is output side. So we would have to keep voltage V2 with it. If we keep voltage with admittance, then it becomes a current source. So it will be a current source. Okay, it will be a current source with the name. What will be the name? It will be y12 V2, because there is no V2 here. on the input side. Here is V1. So we would have to keep V2 with it. Okay. The same will be on the output side. Y21. What will happen? Y21. Coming to this equation first. On the output side. Sorry. This was Y21. This was Y22. Y22. Y22 was I2 upon V2. Sorry, this was V2. Here we have this and 2, and current I2 will flow from here. Sorry, I2 will flow from here, and the voltage V2 is there. And this voltage V2 will appear across Y22. So the Y22 will be like this one. Y22. Okay. Coming to this one, Y21, it has a voltage V1 which is not here. The voltage is located on the input side. Okay. So we would have to keep V1 along with it. And if V is combined with Y, if voltage is combined with admittance, then it becomes a current source. Then it will become a current source. Y21 V1. Okay. So this is the diagrammatic representation for short circuit admittance parameters. So coming upon those ABCD parameters now. Okay, let us start with it. You people may note down or take a screenshot of this. Okay. Our next parameters are transmission, or chain or ABCD parameters. ABCD parameters. Okay. Let us write the matrix equations directly from here. They are written as V1 I1 is equal to A, B, C, D. V2 and the negative of I2. In this transmission or chain or ABCD parameters, you won't see the input side and output side on one hand and on the other hand of is equal to, but you will see the symmetry between the terminals 1 1 and 2 2. Okay. Writing those equations, this will become V1 is equal to A V2 plus B into minus I2. And this equation first, this one is I1 is equal to C V2 plus D into minus I2. Question number second. Here you will see if we take I2 equals minus I2 equals to 0, then this expression will be lost. Here we will find if minus I2 equals to 0, this implies A equals to V1 upon V2. So the voltage upon voltage, that gives us a simple number. Okay. Now again, you will see one parameter is from the input side, another parameter is from the output side. So this one will be a transfer. So this one will be a transfer ABCD parameter, a parameter. Okay. But in the diagrammic representation, we would have to keep V2 with A. What is A? A is something which is a pure number because it has no units. Voltage upon voltage, that gives no units. So if we keep a voltage with proper number, then it gives a voltage. So for A, there will be a voltage source. Okay, you can make the diagram. So this is a practice work for you people. If V2 equals to 0, this implies B equals to minus V1 upon I2. Okay, this is again, what is this one? This one is again a transfer. This one is again a transfer B parameter. And in this case, what will you do? You will keep I2 with this B, I2 with this B. What is B? What is B? B is an impedance because voltage upon current is an impedance. Impedance into current, what does impedance into current give? Impedance into current gives a voltage. So this one will be again a voltage source. You would have to make it like voltage source which is in series always with some impedance. Okay. If from the second equation, if minus I2 equal to 0, so narrating it only orally, we will write directly C equals to I1 upon V2, and what will be D? D will equal to I1 minus I1 upon I2. Here you will see what is C. C is again a transfer because one parameter numerator from the input side and denominator from the output side. And what is C? C is an admittance because current upon voltage is here. C will form an admittance, and admittance will always be in a parallel. So when you will make the diagram, this will become in parallel. What is D? What is D here? D is current upon current. Current upon current gives a proper number because it will have no units. But in your diagram, you would have to keep, because one parameter from the input side, another from the output side, numerator from the input side, denominator from the output side. So you would have to make it like a transfer, and you would have to keep I2 with D, where D is a proper number because current upon current is a proper number because the units cancel. Okay. So you would have to keep I2 current with a proper number, that gives a current. Current multiplied by some proper number constant, that gives a current. So this one will be a current source. And what is a current source? A current source is always in parallel with some admittance. You will make it like that. Okay, transmission or chain or ABCD parameters are done. Now next thing is cascading of ABCD parameters. Suppose here we have one two-port network A1, B1, C1, D1. The input voltage is V1, the current is I1. The output is current I, and here it is V, let us say. If we join this with some other two-port network whose current will be I and the voltage will be the same, that is voltage V, this will have its own ABCD parameters like A2, B2, C2, D2, and the output will be current I2 and the voltage will be V2. Okay, we have done nothing, but cascading simply means joining two two-port networks one after the another, that is output into the input of another one. Okay, in that case what will happen? The equation for first will be equation for first two-port network. First two-port network will be V1 I1 is equal to A1 B1 C1 D1 multiplied by V and minus I, because we have taken minus from here, like this one, because it is also a ABCD parameter. For the second it will be, this will become the input for the second one, because V and I are the inputs for second one. Okay, this will become Vi A2 B2 C2 D2, and the output will be V2 and minus I2. Those are the two individual equations for those two individual two-port networks whose ABCD parameters are to be found after cascading them after joining them. So the net equation for both those two will be, V1 I1 is equal to A1 B1 C1 D1 into A2 B2 C2 D2 multiplied by the input side of first one, and the output side of second one will be included, multiplied by V2 and minus I2. This will be the cascaded equation. This one will be the cascaded equation for two cascaded two-port networks whose ABCD parameters are to be found. So we have done this. So after wiping this out, we shall find inverse ABCD parameters, or inverse chain parameters, or inverse transmission parameters. Take a screenshot of this or note it down. Okay, done. Here we will find reverse ABCD parameters. Okay. How will be the reverse ABCD parameters written? In the previous section, we have written I1 in the LHS side. Here we will write I2, the subscript 2 on the LHS side. Okay, we will write V2 I2 is equal to A, B, C, D will be replaced by A dash, B dash, C dash and D dash. A dash, B dash, C dash and D dash. So the subscript 1 from the input side will be here on the RHS side, V1 and minus I1, and accordingly we will find those reverse or inverse ABCD parameters individually, and then we shall make the network as we have done in the previous sections. Okay, thank you. We shall be bringing another video now, maybe tomorrow, upon other parameters that are left over there now. Okay, thank you.